This is Big Ideas from the ABC.
Welcome, ladies and gentlemen. I'm Gavin Brown, the Director of the Royal Institution of Australia, which is all about bringing science and technology to the people. So it's a special privilege for me to be able to bring a science communicator of the stature of Richard Dawkins to meet with you today. Richard Dawkins was the Schmonyi Professor of the Public Understanding of Science in Oxford and is a long-term Fellow of New College, Oxford. He himself is an evolutionary biologist with a particular concentration on the gene. He has written 10 books, all of them well received, all of them immensely accessible. Interestingly enough, he was elected a Fellow of the Royal Society of Literature before he was elected a Fellow of the Royal Society. So it's great that he's here. His most recent book is The Greatest Show on Earth, in which he patiently goes back and gives the overall case for Darwin's great conception. And of course, that has come out in the bicentennial of Darwin. I also mentioned his book, The God Delusion, which is an advocacy of atheism, where again he speaks about the contrast between the huge explanatory power of Darwin's ideas, the contrast between that and the possibility that one simply shuts down investigation and settles for belief in a mystery. So it will give us great pleasure to hear him. I should say that we had some communication difficulties in working out the format of what was happening today, so that Richard is going to speak for about 20-25 minutes about his book, The Greatest Show on Earth, and he's doing that essentially off the cuff because he was not expecting to do a soliloquy at the beginning. So I'm sure that that will actually make things even more vivid, even more personal, but I think it's only fair to say that. Anyway, without further ado, Professor Richard Dawkins.
What an amazing scene this is. I had no idea that all this people sitting on the banks outside, and it sort of reminds me of the Sermon on the Mount. As Professor Brown... or this might be a kind of revivalist tent. As Professor Brown has said, I was rather taken aback. I had been expecting that he and I would have a conversation together and that he would be asking me questions, essentially interviewing me on stage. When I arrived, I was told that I was supposed to stand up and hold forth. Professor Brown would have been very happy to do that, the thing that I thought of, have a conversation with me, but I thought that I ought to rise to the challenge of trying to do what I was apparently originally supposed to do, which is to sort of talk you through the book and give you a flavour for the kinds of things that are there. The Greatest Show on Earth, the title comes from a T-shirt that I was anonymously sent from America many years ago now, which said, "Evolution, the greatest show on earth, the only game in town." And that has always inspired me, and I've been wearing that T-shirt at conferences ever since. It's now so faded that you can't really even read it properly, but I brought it to life again in the form of the title of this book. I wanted to call it The Greatest Show on Earth, the Only Game in Town, but the publishers vetoed the second part. They thought it was too long. So the implicit subtitle is The Only Game in Town. Darwinian natural selection is not only the explanation for the existence and form and variety of life on this planet, but I think that a good case can be made for the view that wherever there is life, if ever there is life anywhere in the universe, it will turn out to be Darwinian life. And I haven't gone into that in this book, I've gone into that in other books. This book, unlike my previous books, looks at the evidence that evolution is a fact. My other books have taken it for granted that it's a fact and looked at other aspects. So the evidence that it's a fact. I begin with an analogy of a Latin teacher or a teacher of Roman history who finds himself or herself distracted from the business of teaching Latin by a rearguard action of dissenters and history deniers who try to maintain that the Romans never existed and the Latin language was all a 19th century plot to keep schoolmasters employed. That is effectively the situation that evolutionary biologists find ourselves in, not, I'm sure, in Australia, but in less civilized parts of the world, where we do indeed have to contend with those who would deny the palpably obvious to any scientist facts. That, for example, the world is not 6,000 years old, but 4.5 billion years old. The difference is, as Professor Brown, who's a mathematician, will swiftly calculate, the difference is substantial. I worked it out that it's roughly equivalent to believing that the width of North America is about 8 yards. What I thought I would do in this impromptu romp is to use the chapter headings of the book as my bullet points and say very briefly what's in each chapter. The first chapter is called Only a Theory, and you will of course met the idea that because evolution is only a theory, people will use the word theory in the sense of tentative hypothesis that might be true and might be false, and therefore we don't really have to take it seriously. The take-home message of chapter 1 is evolution is a fact. It's a fact in exactly the same sense as it is a fact that we are in the southern hemisphere, for example. Chapter 2 is called Dogs, Cows and Cabbages. I take the same line, the same strategy as Charles Darwin, who used the phenomenon of domestication as an analogy for natural selection. Human farmers, horticulturalists, dog breeders, etc., have shown us the immense power of the principle of selection. The principle of selection being that you take variation, genetic variation, which is simply available in the population, just thrown up at random. Nowadays we would call it by random mutation. Darwin himself didn't use that word, he didn't know about genes. But the variation is just presented at random, and then humans, farmers, horticulturalists, etc., choose which individuals they want to breed from, and over a long period of many generations, actually not so long, we can change a wolf into a Pekingese, or a poodle, or a Rottweiler. We can change a wild cabbage into a domestic cabbage, into cauliflower, Brussels sprouts, kohlrabi, all the various varieties of cabbage, which are so very different. And this is all achieved in a mere matter of centuries. If you can achieve that much change by the power of selection in a matter of a few centuries, just think what could be achieved by the same process in 100 million years. And several 100 million years is what we're talking about in the process of biological evolution. The only difference is that the selecting agent is not really an agent at all. There's no human doing the breeding. It is, of course, blind nature. Some individuals survive within the population better than others. They are the ones who pass on the genes that help them to survive. Some individuals reproduce better. Some individuals are more attractive, better at getting mates, or better at warding off rivals of the same sex. Whatever it is, if you are more successful than the average in the population, then you are more likely to pass on the genes that made you successful. And so over the generations, those genes become more frequent in the population, and the process is exactly the same as the process whereby generations of farmers, gardeners, etc. have produced the dramatic changes that we see. The only difference is there's no deliberate selection. The only difference is, willy-nilly, some individuals survive better than others. Some individuals are more successful at reproducing than others. I use a strategy in the book which I call softening up, which is somewhat similar to what Darwin himself did. Chapter 3 is called The Primrose Path to Macroevolution. So taking off from domestic selection, selection by farmers, etc., going through sexual selection, which was Darwin's other theory, sexual selection whereby females choose the most attractive males. You can sort of see a female bird choosing males for their bright colours, say. Bird of paradise, perhaps. You can kind of see a female bird as an inadvertent artificial selector. The female bird is in rather the same position as a human farmer or gardener, choosing which are the prettiest roses to breed from, which is the most abundantly lactating cow to breed from. Moving from that to females to insects, being selected by flowers. Flowers need insects to act as pollinators. They bribe the insects with nectar. Once again, you can kind of see the flower with its bright colours and its seductive scent, seductive fragrance, as equivalent to a human breeder, or rather the insects could be seen as the equivalent of a human breeder choosing those flowers which are the most beautiful. Just as human gardeners choose the most beautiful roses, so insects, long before humans came along, insects choose the most beautiful flowers, or the most fragrant flowers, or the most nectar-bearing flowers, and choose them by the act of entering the flower and pollinating, carrying the pollen which bears the genes that made the flower beautiful in the first place. So it's an automatic process, not a deliberate process, but apart from that, it's just the same. The next chapter, chapter 4, is called Silence and Slow Time, and this is an exposition of how we know how old fossils are. It's a bit of a digression. I think it's rather an interesting digression. It is now possible to date fossils by dating igneous rock, volcanic rock, that are in the vicinity of the fossils, and I explain the physics of that dating process. It's how we know that fossils are hundreds of millions of years, even thousands of millions of years. I was thrilled to visit the South Australian Museum yesterday and be shown the Ediacaran fossils, which I had no idea are so beautifully preserved. And these are extremely old. The oldest major fossils that we have in the entire world are from this state. The next chapter, chapter 6, Before Our Very Eyes. Mostly evolution is too slow for us to see happening. The human lifespan of a few decades is just not long enough to see a process that takes millions of years. But there are just a few cases in nature where evolution is so fast